Welcome Statistics 1 students to week 14 of maintenance. The first question we have today is a representation of data question. There are all exam questions actually today. The distance of a student's home from college, correct to the nearest kilometre, was recorded for each 55 students, and we've got this table here. You notice we've got distances of 1 to 3, then 4 to 5, 6 to 8, 9 to 11, 12 to 16. So hopefully you notice as you're looking at this that the class widths are different. They're not all the same. Then we've got the frequency or number of students below that. Dominic is asked to draw a histogram, and here's his supposed histogram. Now, we are meant to give 2 reasons why it's not a correct histogram. Reason number 1, of course, is the bars ought to be touching, connected or touching in a histogram. And the second issue is that he should have used frequency density for the y-axis because the class widths are different. So he should have used frequency density for the y-axis because the class widths are different. Okay, so that's the first question. Nice and easy. Sorry about the handwriting there, chaps. Okay, right. Number 2, this is also same kind of deal, representation of data. Barry weighs 20 oranges and 25 lemons. Okay, 20 orange, 25 lemons. For the oranges, mean weight, 220 grams, and standard deviation. Okay, let's maybe do the lemons in a different colour. For the lemons, the mean weight is 118, standard deviation is 12. We've got to find the mean weight of the 45 fruits. Okay, so obviously we want to find the total of weight of all of the fruits. So we've got 20 oranges, and then we know the mean weight's 220 grams. So we're going to add that, multiply that by 20 to get the total weight of the oranges, and then the total weight of the lemons is going to be the 25 times the 118. It's there. That is their mean, and then we're going to divide that by the 45 fruits that we have, and this is giving me 163.3 recurring grams. Now in the second question here, we've got the individual weights denoted by XO for orange and XL for lemons, and we've got to find the sum of x squared O and the sum of x squared L. It looks like there's just an error here in my copy. And we've got to find the variance of the weights of the 45 fruits. Now variance in this case is going to be equal to the sum of x squared O plus L, right? So what we want to do probably first, and then divided by the 45, and then minus the mean that we found previously squared. Okay, and that will give us the variance, which is what we're trying to do. So what I'll first of all do is I'll probably find the sum of x squared O over 20 is equal to, because that's how many oranges we've got, minus the mean of the oranges. Now we know the mean of the oranges is 220, should equal the variance of the oranges. Now we know what the standard deviation of the oranges is, that's 32, so the variance would be that squared. And we just rearrange this, and then we can find out what the sum of x squared O is. So when I rearrange this, before I got 988,480. So that's the oranges. Now we're going to do the same with the lemons. So the sum of x squared L over, now there's 25 of these guys, and the mean weight is 118 for these guys. And we've got a standard deviation of 12, so the variance would be 12 squared. Okay, Okay, so we rearranged that, and we now find that the sum of x squared L is equal to, now for this one I got 351,700. So I can now pop this all together. I can go, so I'm going to use this formula over here, right? This one. So I'm going to do 988,480 plus the 351,700. I'm going to divide that by the total of 45 lemons and oranges that I have. Then I'm going to subtract my mean squared, and this will give me my variance, which is what I'm trying to find. Now when I do that, I'm getting a variance of 3104. Oakley dokley. Moving on to the probability question. So Deo is choosing 2 digits at random without replacement from this 9-digit number here. We've got to find the probability that the 2 chosen digits are equal. So you could get 1, 1, you could get 3, 3, or you could get 5, 5. And those are the only ways that you can get 2 digits equal. So 1, 1, there's 9, and you've got 2 chances of getting it first off. Then if you picked it out, you've only got one of those ones left, so 1/8. And then the 3s, we've got 4 3s, so that should be 4/9. And then the second pick, there's only going to be 3 of those 3s left, and there's only 8 digits left. Now for 5 5s, it's 3/9, because there's only 3 of them to start off with, and then the second pick would be 2 8s. Now if we add this all together, this ought to give us the total probability of getting 2 digits the same. Okay, now when I add those all together, I'm getting 5/18 is my final answer. Find the probability that 1 digit is a 5 and 1 digit is not a 5. So you could get 5, and then you could get, we can write not 5 like this, not 5. Or you could get not 5 and then 5. So the way we show this is we could just go 5, which is 3/9 chance. Then the second pick will be not 5, which is 6 out of 8. And then we just multiply it by 2 to represent the 2 different ways we could do that. And that is giving me a chance of 1/2. The next one, C. Find the probability that the first digit Dale chose was a 5, given, so first digit 5 given second digit not 5. Okay, so what we're actually thinking here is we're trying to find probability of 5 being the first digit. We'll go 5 first digit given not 5 second digit. Now the way we write that, we find the probability of 5 as our first digit intersection with not 5 as our second digit, divided by the probability of 5 not 5 as our second digit. So what's the chance of getting 5 intersection not 5? How do we work out that? Well, you getting a 5 the first time is 3/9. Not getting a 5 the second time is 6/8. Okay, that's that. What's the probability of getting a 5 the second time? One way of doing it is if you get, you can go 5, not 5, or you can go not 5, not 5. Now, we already know what this one is. It's this, which with 5 intersection, not 5. So it's 3/9. Is that 1/4 times 6/8? That's 1/4. So we've got 1/4 there. So this is 1/4. And then this one here is simply not 5, which is 6 out of 9. And then the second one, 5 out of 8. And this gives us 5/12. Okay, so now we're ready to pop in all of the details into our formula. So if I do that, I'm going to get 1/4 on the top, It's a bit messy. Let's make it a bit neater. 1/4 on top. Then I'm going to divide on the bottom by 1/4. Whoops, that's messy. 1/4 plus 5/12. Now, when I work this out, my final answer for this one happens to be 3/8. Now, the next one is actually a discrete random variables question, but it's in the exam it carried on from what we've just done. The random variable x is the number of 5s that Dale chooses after 2 picks. Remember, he's picking 2 up. So draw up the table to show the probability distribution. These are the values of x here. Obviously, he can get 0 5s, 1 5, or what am I trying to get for? 2 5s. And the probability that x is equal to x. Now, 0 5s, 0, the way we get that is not 5, not 5, which we worked out here, right? Funny arrow, so that's 5/12. To get 1, sorry, that is going to be what we did up here in part B. 1 digit is a 5 and 1 digit is not a 5, so we found that to be 1/2. And then 2, well, that's 5 5. So it's like 3 out of 9 times 2 out of 8, which gives us, what does it give us? I think that's 1/12, isn't it? Let's just quickly check that. 2 over 8, 1/12, yeah, 1/12. And that's that one done. It all adds up to 1, which is perfect. Okay, so the next one is permutations and combinations. These can always be a bit tricky, but I had little difficulty with this one. That was quite easy, actually. So hopefully we get something like this in the exam, hey? So we've got to find the number of different ways, 9 letters, so it's helpful they tell you that. You don't have to count it. The word aggregate can be arranged if the first letter is R. Okay, so if the first letter is R, that means we've got R, and then we've got 1, 2, 3, 4, 5, 6, 7, 8 letters to rearrange. But you should notice that we've got these ones are the same, and then we've got 2 E's, and we've also got 2 A's. So we've got some repeated letters there. So what we're going to do is the number of ways that we can rearrange those is 8 factorial. But because we've got 3 G's, we're going to have to divide it by 3 factorial. Because we've got 2 A's by 2 factorial. And because we've got 2 E's, it's also got to divide by 2 factorial again. Now, when we chuck this into the calculator, we should get 1,680. Now the next one, we've got to find the number of different ways that 9 letters of the word aggregate can be arranged in a line if the 3 G's are together. So G, G, G. So we treat that as like one thing. And then both the A's are together. So A, they're going to be combined. And then E is together. Now, what have we actually got left after that? That's a good question. What is left after that? We've only got 2 letters, don't we? T and R, I think, is the only letters left. Okay, T and R. Now, so you can see what we do is we treat each of these blocks as one letter because they've got to stay together. So we just rearrange them as blocks, and because they're all the same, it doesn't matter what order they are within those blocks because it's an exact duplicate. So in essence, we've got 1, 2, 3, 4, 5 things that we're arranging, and so the answer will just simply be 5 factorial, which is 120. Now the next one, we are trying to arrange the letters so that the consonants and vowels occur alternatively. Now, what I noticed when I did this is that I've got, in terms of consonants, I've got 5 consonants and I've got only 4 vowels, which means the only way I can rearrange them so that we're alternating is if we start with consonant. So consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. Okay? Because we've got more consonants than vowels, that's the only way. We can't start with a vowel, otherwise we'll end up with a double up consonant at the end. Now, so what I decided to do with this is treat the consonants as one group. So I'll do the consonants in red. So just for instance, we've got G, 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 and then I think we've got R and T, right? So there's those guys. And then we can look at the vowels. And so for the vowels, we've got A, and we've got E, E. Now, the ways that we can rearrange the vowels, sorry, the consonants, is there's 5 of them. We can arrange them 5 factorial ways, but notice that we've got 3 of them, the G's, are repeats. Now, for each of those ways, we can also rearrange the vowels, and we've got 4 vowels, so there's 4 factorial ways of arranging them, but you notice that they've got repeats, so we've got to divide them by 2 factorial for the A's, divide by 2 factorial for the E's. Now, when we put this all together, what do we get? Well, I'm getting 120 again for this one. Okay, so for every 5 factorial divided by 3 factorial way that I can arrange my reds, then for each of those, there's 4 factorial divided by 2 factorial divided by 2 factorial ways that I can arrange the greens. So altogether, to find the total ways, I multiply those. Now the last one here is the number of different selections of 4 letters. So selections of 4 letters of the word aggregate which contain exactly 2 G's or exactly 3 G's. So let's start with the 2 G's. So I've got G, G, and then what am I allowed to choose from? The rest of the words, letters that I can choose from are A, R, E, A, T, E, because I'm not allowed another G. So, alright, so for those 2 that I choose, what can I do? Well, hopefully you can see there are repeats here. So the easiest way to do it is to start with A. So I can go AR, AE, AT, and that's the, oh, and then AA, of course, I could have AA. And then we'll go to R. We won't do RA because we've already got AR, which is the same. I can go RE, RT, and I won't repeat RE again. And then I can go with E's. So E, I've already got EA, I've already got ER, but I don't have ET, and I don't have EE. Now I've got almost everything, I think. In fact, I have got everything. So there is, how many have we got there? 8 ways. Now let's consider when we've got 3 G's. We've got GGG, and we've got to choose one from the rest of these. Okay, you can see, well, that's a repeat, so you can ignore that one. That's a repeat, so you can ignore that one. So there's 4 ways that you can choose your final letter there. So in total, 12 different selections, 8 plus 4. And that, I think, brings us to an end of the statistics maintenance for the week. Hope that's been helpful, team. Do let me know if you have any questions or concerns. Thanks, take care.